Hello everyone. Good afternoon. So today our talk will be the title about the software security era, the past, present, and the future. This talk is actually a series of from Harun Mir in 2010 and from Nikita Tarakanov in 2014. So after that, we don't see any the past, present, and future about the software security era. So today we're going to present our own research. So who am I? So my name is Nafiez. Everyone call me Nafiez in the crew. So I'm an independent researcher, and I'm also working as a penetration tester in a enterprise company. So I'm part of the HITB CTF crew for Malaysia. I've always had a passion in vulnerability research and reverse engineering.
Hi everyone, I'm Jaan. I'm currently working in COMMSEC as a threat researcher. I'm also part of HITB CTF crew. And then I'm passionate in vulnerability analysis and malware reversing.
Okay, I'm going to tekan for you.
Alright, this is the outline of our talk. First we will talk about overview of the paper, followed by introduction. Then we will discuss about items that we are focusing on. And finally, we will discuss the past, present, and the future of software exploitation in our point of view. Protecting software against malicious attack and to reduce risk and attack surface, continuing software to work correctly under potential risk. So what is software security? It is basically protecting against malicious attack and to reduce the risk and attack surface. Software security is a wide area. We will cover numbers of aspects in securing software. We can take an example of what top 10 application security risks.
So next one, introduction to our talk. So yeah, software security is large. It consists numbers of types of issues that can be highlighted, such as SQL injection, stack overflow, buffer overflow, integer overflow. So many that it covers in the software security. So today our talk is mainly focusing on the memory corruption. Why we choose memory corruption? Because it still exists these days, although there's a lot of mitigations being present outside, and we have seen numbers of papers, talk and debates about this, and also we will focus on this evolution of exploitation and the mitigation. And today our presentation will be focused on the Windows and Linux environment.
All right. In software and memory corruptions, developer playing a main role in this problem because software itself is coded by humans and human is not perfect. So do software. The issue for software security will always existing as long as software is being developed by human. But this issue can be reduced by introductions of protections of the vulnerability mitigations techniques and secure programming mindset. From the security point of view, for example, vulnerability researcher, our task mainly focus on what is happening and what can be done. So as a good example, we need to determine crash state by debugging the memory corruption by looking for types of issues to categorize the vulnerability. By doing that, we could determine the exploitability, and then we can get more information if it is really exploitable from fuzzing result. All right. In the early of 90s, we can see a number of buffer overflow paper being released. For example, tutorial by March released first, followed by one in frag 49. Most of the attacks are involving buffer overflow. We can see a lot of effort being put as a defense in memory. However, during that time, none are success protecting memory corruption issue. There are more Windows exploitation in the world compared to Linux, and is used to trivial to exploit. The simplest technique can be used, which is a jump ESP as a return address.
So in the past, it used to be as a trivial like this, where you have a stack and then you can just fill all the gaps inside. It's like you pour a water into a glass and then it spread out, and yeah, so this is how easy it is in the past. So you can just Perl -print and then you have the hex number and then you times on how many buffers it has, and then you put your own shellcode, and then that's where how you easily get and then you just put the return address and you can get the shell.
All right. Since Morris worm being spread, they start to have a lot of paper and tutorial regarding memory corruptions. Sorry. So we are mostly being inspired by Oblique1 and Oblique1 Buffalo 4 tutorial, and in the era of Windows, there's a lot of memory exploitation technique being introduced. And then okay.
Yeah, so we can see the evolution of the exploits is being more harder and harder. It was introduced in Windows Vista, which is shipped with the SLR during that time. So, and during this time period, as we can see numbers of techniques being introduced to public, such as a Linux SLR bypass, ROP techniques, which is introduced in 2010, and also we can see a lot of in the wild exploit used or involved in attack, and we can see a pawn-to-pawn challenge being introduced during this time. So it is a competition where everyone can have their own exploits, and they just need to find their list of target.
Year by year, we can see improvement being made and bypass being introduced. Exploitation is no longer trivial to exploit. For some cases, an exploit might require brute force the ASLR in order to bypass it. For example, in Ubuntu, we might need to guess for 4096 times until we can get the offset to the ASLR. And yeah, from what we discussed just now, we actually seeing more Windows being exploited in the wild than Linux, despite of most of the tutorial is being introduced in Linux.
So let's take an example of a simple integer overflow that we found in 2013. So we are not really sure which patch actually patching this issue, because that time when I do the fuzzing and then I posted it on Twitter, and then I just I think I removed some of the API, and then there's one guy, I think I can't remember his name in Twitter. He posted the same screenshot like me, and he told us that the vulnerability is already being patched somewhere around May 2013, but we are not sure which one is actually patching the vulnerability. So the finding is we inspire by Nafiez's write-ups. So you can see the link below, and it's actually a simple integer overflow. So in a two complement system, absolute value of integer minimum is actually higher than the integer max. So by dividing integer minimum with -1, you can get the integer overflow. So the bug was spotted in the scale viewport X API, and you can see the highlight in yellow, the integer xn in the second parameter of the API. You can see we can just put integer minimum there, and then you can easily get a integer overflow. So the function of this API actually acts as modifying the viewport for a device context using the ratios form by the specified multiplicand and divisor. So example of our crash path on the top that we commented and the proof of concept is a simple few lines of C that you can just get a BSOD, and this is how we didn't manage to get a video to show today. So this is just an example of it. So how you going to compile this? You just need to install a Windows 7 without patch. It's a fresh install, and then you can observe the blue screen after you execute the code.
Let's take a look at the present time. In present time, we are actually taking from 2011 to 2018. In early of 2011, we can see there's a rise of exploit kit, followed by the browser golden era, which is using a lot of heap spray. And in 2016, Intel introduced hardware-based mitigations called RipBlob. And in 2017, Windows reading in mitigations. We will talk more about this in the coming slides. There's many news regarding attacks related to CPU in 2018, although has been a lot of research by a few researchers like Joanna and Chris Kaspersky in last few years.
So we can see hundreds of memory corruption that yet still exists these days, although there's a lot of mitigations being introduced. And from our observation, we can see the code, or why is it still vulnerable, is because of the legacy code was still implemented in their application. So regardless of what kind of applications or softwares, but yeah, it's still the mistakes by human. And yeah, the rob chain bugs is now like a common in exploitation. So regardless of OS, even if you do exploitation in Linux, still need a rob. So we can see memory mitigations or protection are effective these days. Why I said it's still effective, because you need a chain of vulnerabilities in order for you to gain some code execution or system or root in a target itself. So this we can see from pawn to on results, where year by year you can see a lot of numbers of vulnerability being involved. So you can't simply like use one single Internet Explorer vulnerability to exploit to gain a system. So it needs some numbers of vulnerabilities. For example, like the IE from the IE to the kernel itself. And in the IE itself, it might require 2 or 3 vulnerabilities. For example, like you have the use after free, but you need an info leak, so that after that you get the info leak, you need something to chain into the kernel. Then that's where how you can gain the code execution. So we can see this example as well in the latest Windows 10. Those that are still the old vulnerability that, for example, like use after free is no longer works properly in a Windows 10. So for example, we can see it jumps into a null pointer dereference. So we have reported some issues on IE on Windows 10, and Microsoft just informed us that this is an null pointer issue. So there's no chance for it to get to being exploited. So in the present, we still can see this type of attack still effective. So for example, like Windows 7 SP1, so we have the SEH override. So we need to have numbers of chain of rob here. So if you compare to the Windows XP SP3, we can see we can jump from the SEH to the virtual protect rob chain itself. So that's how to differ the difficulty of or the challenges of the exploitation.
As we highlighted earlier, this day mitigation has killed many bugs, 150 classes along with the corresponding exploitation techniques. Looking at the present timeline, we observe that Microsoft actively improving memory mitigations. All this helps to improving protection as well. So let's take a look at the evolution of Windows mitigation. Windows first introduced NX-DEP, then followed by SCH hop and ASLR, and then MemGC, CFG, LCG, RFG being introduced as well. They have also mitigation in kernel level by introducing Hyper-V, but nonetheless, each of these mitigation has its own bypass techniques.
So let's take a look on the Linux mitigation. We don't see much improvement. We've seen a lot of academic papers, but none of it apply into the real world. So for example, like PAX, GR Security has been doing a good example in Linux mitigation. And we can see the people in the team has been done like since early 2000 until today, they're still improving. So even for like some of the Microsoft mitigation techniques, almost similar like how the PAX work. So in Linux mitigation, we still can see like an NX, DEP, the stack guard, ASLR, and then the PAX is like everywhere. It's like every year they have some new improvement. For example, like the kernel level. And also LLVM for the control flow integrity. So this CFI is basically act as a CFG in Windows.
Next, we will talk about the CVE 2018-10097, which is a GNU SHA UT's buffer overflow that we found from fuzzing it. SHA UTs was introduced in 1994. The package of SHA UTs containing SHA, unsha, UU encode, and UU decode. The purpose of the tools is to create and manipulating SHA archive that can be readable by email. So from here, it sounds like a very good remote target. It is very widely used in Linux, and it's good pace if you it's not updated since 2015. We randomly pick a target, which is unsha, and then we create a test case using SHA command and throw the corpus to AFL. Within 4 hours of fuzzing, we will manage to get 5 unique crashes, but all of the crashes lead us to the same result. So we decided to stop and look into the issue, although we have changed the corpus many times, but there's no much luck that we can find any new vulnerability. Next slide will be the quick analysis.
So this is the example of the AFL results from our fuzzing. So how do we fuzz this? So we just use a laptop with 6 gig of RAM, and then we managed to get this 5 unique crashes within 4 hours. And yeah, so the result analysis was a bit trivial. It still happened in 2018. So you can see the example here. We have listed like number 1, 2, and 3. So the first one, the page size was set to 8192, and then at the other line, so we can see RW buffer actually allocating the page size that has in this get page size. And then the third one is the buff size should allocate at 192, but unfortunately RW base size is not equals to the memory page allocation. When we do observation using the val grind and some output from this SN, the address sanitizer, so we figure out it's only 4096. This issue we figure out in a Ubuntu. So we reported this to the full disclosure because we can't see. I can't remember, but we sent email to the GNU team member, but none of them are picking it up. So we just push the email to this full disclosure, and then Linux, Red Hat Linux is the first to take the action to fix the vulnerability, and then followed by the Fedora, and then few weeks after that it followed by Ubuntu. So in 2018 or in the current times, we can see that all vulnerability class still exists, although some debate that they mentioned about things are not going to happen. So we can prove to them that this issue will still exist. So it's just the matter of the code itself. Is it updated or not? So if it is still using legacy code, so it needs more, need to dig more on that and figure out if there's do some audit on this. So from this observation, we can see fuzzing could help to speed up finding memory corruptions, although it might take some time, but it's worth the time so that you can actually eliminate and reduce the attack surface to the application and to the OS itself.
Since there is more and more mitigation method being introduced every now and then, memory corruption exploitation is getting much more harder. There is also hardware-based mitigation and bypasses, for example, spectral and meltdown. This is proven that this attack can be done from user mode to hardware layer. If you can see from our CVE 2018, the old vulnerability types is actually still remain, as there's still many legacy code out there without any updates.
So we can, as I mentioned earlier, there will be more chain types of vulnerabilities will happen in the future. So, and you can see an example of a pawn to all these things are getting harder because of these mitigations itself. And we will see more hardcore research on the CPU. So for example, like the Spectre and the Meltdown, which is attacking the modern CPU. And the software-based mitigations might require to have more improvement on that. And also, the software shouldn't need to rely on the hardware level, because for some cases, it doesn't even rely on that kind of layer. So yeah, we are still waiting for the technology from the Intel CET, which is known as a RIPROP. So it has, as per now, we still can see in their documentation the shadow stack and the indirect branch tracking. So the shadow stack actually acts as a second stack for the program. So yeah, it might create another some fake stack on that, and then that fake stack will act like nothing can be executed on the code on the OS itself. So it's separate from data stack and can enable for operation via user mode or supervisor mode. So the shadow stack actually used to protect the return address and also defend against the ROP. But yeah, we still don't see the thing yet, but it's still on the plan by Intel. So we might see another bypass in the future. So yeah, we might not know. And the second technology they use indirect branch tracking. So where they create a new instruction named end branch. So this end branch actually, from our observation, is almost similar to the hardware, to the software layer, like CFG, SCG, where it mark the invalid indirect of a call or jump. So if you have bypasses on the CFG, so you can just pass that, and then you can. So this is on the hardware level. So the indirect branch tracking actually to protect the free branch against a job and the cop. So for example, like a jump-oriented programming. Okay. So as a conclusion, so yeah, we still see vendors is like a cat, and bugs are like the mouse. So they're trying to catch, but still, yeah, it's like how you watch the Tom and Jerry. It never-ending story, even since like the 80s era or 90s era, but still until today, even I watch with my kids, like almost the same. The cat still cannot be catched by the mouse. So same goes to the industry, where vendors are still doing the same thing. It's just we don't see the mouse. So last one from us is about the bugs or the vulnerabilities will still exist. It's just the only challenges is the one that makes everyone getting explored when they try to do exploitation. So we will see more advanced attack in the future and the bypasses, and also advanced defense mechanism. That's all from us. Thank you for listening.
Thank you, Nafiez and Jaan. Are there any questions from the audience? Oh, come on, guys. I see a lot of Hacketbox faces here. You must have some interesting questions for them. Okay, I'm expecting you to bother them later on because they'll be around for a while. At the coffee break now, or at the networking drink, or at the after party. Give it up one more time for Nafiez and Jaan.